In this video, we're going to talk about interfaces in C#. But before that, we should understand what exactly an interface is. Now, in my previous video, you have seen that we created an class by the name file data access, created another class by the name database data access, and there was a base class by the name data access in order to explain to you abstract demo. Quite similar kind of idea I'm using in this video itself, known as interface demo. I'm creating an application by the name interface demo, and what I want is that a similar kind of feature. So what I'm going to do, simply instead of writing the code, I'm going to, or let it be, I'm going to create a file data access class once again here, which has, and say another is database data access, right? Right, this is how it is. Now the file data access and database data access, they have like this string. There is a file path that you are going to send from outside, and we are going to make it read only also, so that it can be set only via constructor. So set your default constructor, and then I want also a parameterized constructor here, say file path, and we're going to set here this dot file path. I think I made a mistake here, so let's just rectify file path and say this has, I need a functionality over here obviously in order to access the data and return the data to you. Quite similarly, in the database data access also, I'm just going to copy and paste the similar kind of code because it's more or less same. Database data access, and over there I have got db path, suppose data member, and the constructor names are going to be this way and this way, and its name, let's say db path. There it is. db path is equal to argument db path. Now, I want a property here which I want a functionality first of all which accesses data, and I want a property here which returns that access data to you, because the method is not going to return anything, as simple as that. So now I do not have any as such data member in common, but I want to create a base template, means a base type. And in that base type, what I need, whatever base type it is, only two things to be present: the property as well as the function which I want across all my classes here in my application. Similar kind of function. The purpose of both these, first the function is going to fetch data from either file or database, and the other thing, that is the property data, is going to return that fetch data. Whether it's a database or file, it doesn't matter. At the end of the day, that property is going to return the data. So this is kind of a situation where I do find that there is no data member in common, only functionality is common. And in that case, C# provides you, or object-oriented language features or object-oriented programming features provides you a nice mechanism saying that you can declare something called an interface, and that interface is going to be a collection of, though I'm choosing class here, don't mind, interface is going to be a collection of just simple methods or the functionalities that you want to be common amongst all the uh, classes. Let them take this common functionality from this base template and then implement their own way. But this base template is, unlike the abstract class, is going to hold only certain list of functionalities. No common data member amongst the classes will be placed here. So I am creating an interface by the name I data access. So it depends on what you want. See, the same program I'm using to show you two different implementation depending on the situation. In my previous situation, in my database data access class that I created, I had a path, I had data members over there, etc. Right now I don't have those. I have them present here, right? So I can have also this kind of string db data, and then in the file data access also ditto same, I can have string file data. So I just want a common functionality to be injected in each and every class. And for that, I'm creating an interface which can hold only functionalities. And this is how we declare interface in C Sharp with a keyword interface and then the interface name just like class. The difference is that in the naming convention, uppercase I comes into the picture. That means every interface name starts with uppercase I and then the actual interface name again in Pascal casing style, right? They should not be like data access interface. The keyword should not be suffixed or prefixed in any kind of type name. Like I told you already, in case of class, it should not be data access class or data access interface in case of interface. They, there should be a distinction between the name of the class and interface. So we just prefix uppercase I with the name of the interface here, right? And this is how interface is declared. By the way, the access specifier for interface is ditto same, public and internal. These are two access specifiers for interface in C Sharp, just like class. But what about the members? How do we declare? Can we have data members? No. Interface doesn't hold any data members. You can declare only functionalities here, such as properties, methods that you want. And first thing is first, all these properties method that you are declaring, they're by default abstract. Point is, we are just writing the signature here, just the declaration of the function or the property here. Implementation will be there in the child classes. That means we are going to inherit this interface in classes. Practically, we do not use the term inherit, we use the term implement. That means we are going to implement this interface, means interfaces all members in our classes. So how does this declaration look like in comparison with abstract class? In comparison with abstract class, like we are supposed to use a public access specifier so that every class can take it and implement it and they are publicly accessible member. Otherwise, what is the point of having a abstract method, isn't it? Here it's different. You do not have any public access specifier to declare the members with. Second, in abstract class, there could be abstract and non-abstract members also. That's why those which are abstract members, we declare them with abstract keyword. But in interface, we do not declare them using abstract keyword because by default, whatever you type inside interface is abstract. So simple thing, what is the return type of the function? Void, and that's my get data function. And what about the property? String data with just get accessor and protected. That's where the question comes. Can I have protected set accessor here or not? As far as I am concerned, right now, there is no question of protected here. So no, you are not going to do that. So I'm not going to have the set accessor at all. I'm just going to have get accessor here in this case. That's all. Okay, so this is how the this is how the interface looks like right now. By default, it's internal right now since I have not used any kind of access specifier with it. And the members simply return type and the function signature without public keyword, without abstract keyword. Never ever try to mention even. That will be a compilation error if you try to declare it with any access specifier in this interface. So by default, the members are public. By default, the members are abstract. That's why they are never declared with those keywords. Once you say interface means it's a pure abstract class. There's no way it can have a non-abstract member like I had in my abstract class. Now, this is how an interface in C# looks like. So database data access is going to implement this interface. So I'm going to write I data access and immediately it will ask you to implement the interface. So your job is you can manually write this, but Visual Studio provides you a fantastic facility. Select this interface name as soon as you put or focus your mouse on that interface name below, you will find this kind of underline symbol and a nice button showing that you can implement the interface. There is one more option, I'll talk about it later, implement interface. So you click on this, immediately you get all these functionalities here. Or what you could have done is that you could have selected this immediately here on the left hand side in the Visual Studio comes that immediate implement interface here also. You could have done the same, right? So this is how to implement the interface right now. And as you can see, I have got this string data property with a public access specifier. Now it has got a much simplified line and there is no get line here as because it has got only get accessor. So you can just avoid the get and directly write data returns this dot db data like in this way. Actually, if you want to understand it properly, then this is only get accessor which returns you db dot data. This, if you want to simplify, sorry, it's just DB data, I forgot, DB data. But if you want to simplify much further, then you can also write a property which is a read-only property, right? You can write directly public string data, then this arrow operator, and then just DB data or this dot DB data. This is also fine since it's just a read-only property. Okay. Now, public void get data will obviously have the code, and this is going to say this dot db data is equal to, just you can write db data, doesn't matter, you need not to write always this keyword because there is no conflict of variable names here. Here in the constructor it made sense, but not everywhere. Right now this is going to be, say for example, database data, and you are going to pass the path here. So this is, just a second, I think I'm making lots of mistakes. Sorry for that. Database data. So this has been set and the property will return this. I don't have any set access here also. And ditto same in the file access, you are going to implement these interfaces here. Once again, this is data access interface. And this data access interface, now you know the technique of implementing. Don't take a risk of manually hard coding it. Do it in this way. Data which returns file data, and this get data method sets, or retrieve data method sets this file data is equal to file data. Okay, this is how it is. Now let me see, that's my file path, string file data, public file data access, etc. All these constructors written, database etc. written. This is how you implement an interface. Now, generally, this is a technique of implementing the interface which is known as implicit interface implementation. Okay, this technique of implementing all these members is known as implicit interface member implementation. Now, there is one more type of implementation also known as explicit implementation. We'll talk about it later. Uh, Now the next thing is, when you declare in this way or implement in this way, you can access also. So go back to program.cs. Say for example, you are creating that same application where I have the static void print get and print data. Suppose say get and print data functionality, where this is what you are doing. In the main function, first of all, you are creating instances of, say, file data access, or it can be much better actually. You can give a choice to an user like this way. That is, say, for example, I have static void show menu method, first of all, and in that show menu method, you are going to print to the user one, access data from file, and let me copy this and paste it below. Once again, say access data from database, right? Call this method from main, hmm, say show menu, and then let's ask user to enter a choice. You can write a method also, get choice, like this, which doesn't exist right now, but when written, I expect this method to uh, expect that nothing to be passed to this method, but the method should return at the end of the day some kind of choice to me. What is my choice? Right now this function doesn't exist, so I can select this, then hover around it, and I can get create method like this. So immediately it will create a method get choice, so I can write my code console.write and say a little bit of extra line, new line character, and say enter choice. What do you say? So enter choice, one or two. Please enter the choice, and I'm going to accept the choice, and I'm going to return it. So if I want to return, I would like to parse your choice. So console.readline, you take this value and you are going to convert it to integer and return this, which I'm going to call it from here. Once I have got the choice, then based on that, what I'm going to do is that I have a switch case, and in that switch case, maybe I'll not write it here even. So I say create uh, data access source. So file or database. Just a method create, and in that create method, what I want you to do is that I want you to pass your choice, and that at the end is going to return me. That's a bit interesting. I want a reference of uh, either a file data access class object, or I want a reference of the database data access class. But see, I have declared a variable of type interface. So whatever instance this method is going to create, that return reference is going to be stored into a data access variable, which is of type the interface. That's clearly an upcasting like you have seen earlier. Now the method doesn't exist, so let me create that method. And once you create that method, then I'm going to use a switch case here, and based on that switch case, now first thing is if you are passing choice like this, then I'm going to write if my case is 1, I am going to create here obviously with a break statement an object of file data access, but if the choice is 2, then this is what I'm going to do. And for this entire thing, let me say I data access, I declare a variable data access. Okay, and this data access will be null initially, and inside case 1, data access variable is going to store new file data access. So it's going to store a reference of the file data access, and here it is. I'm going to create an instance of database data access and going to store reference of it in that data access. And otherwise default statement is data access is equal to null, or you can say that enter a default choice, and at the end of the day I'm going to return from here this data access variable, which either holds a file data access instance object or database data access instance reference, not object reference. So once again, depending on each choice, either I'm creating file data access or database data access instance, and that reference variable is going to be stored in a variable of type base, that is I data access. I can do that. It's whether class or not, it doesn't matter. After all, it's a base type. So I can store a reference of a child in a base variable, and then once I have got the reference, my objective is to pass these to the function get and print data, which is also expecting a data access instance here. Okay, and this is what I'm going to call from here, data access get and print data, to which I pass this data access. Look, everything I'm doing is to interface hardly, and two places you have seen me using the actual class name, isn't it? So here it is. I can get my object created and then store it into a variable, and then simply pass it to that get and print data and get it called here like this way. Get data method I call, and then I use my property data access dot data property to print that data. In the meantime, I guess we are supposed to pass the path also. So to the file access, I pass dot slash data dot txt, and to this I path that connection string like the last time I did. Database is equal to, say, for example, product db. I don't have any database like this, and suppose say this is stored in a database server with an IP address 192.168, or if it's in the local machine, maybe local host, you can say, and then some kind of user ID. If you have that kind of facility, you will find it later. Okay, when you learn about ADO.NET, etc., etc., you can see that we can use practically user ID, password, and account details to log into that database, and password is equal to, say, SQL Server 2017, like this, right? So yeah, there it goes. So this is what I'm doing. I'm just saying that given the choice, you are going to create an instance of a class and store that reference upcasted in an interface variable. This interface variable you are going to pass to the method get and print data, where you call this method and immediately you get it invoked, right? So this is how it is. If you now run this application, then hopefully it works fine, isn't it? So this is what I'm doing. Access data from file or access data from database. I say access data from file. I get the file data. I say that I didn't provide any do while loop, so you can keep on executing it to database data, right? I just didn't print the path. Maybe if you want, you can print the path too. Not a big trouble. So right now, this way, have you noticed the way I have written my code? I created an instance of a class, but then passed the reference to the base class variable, base interface variable. I'm sorry, I used the word base class. It should be base interface. So the base type is an interface to which I pass this or store this reference, and I use this to invoke the get data method. I use this to invoke the data property. In this way, when you do that job, this is known as explicit interface member invocation. Explicit? Yes. You are just looking at an interface. You do not actually inside the class what is there. You feel that you are invoking the interface members directly. So explicitly you are invoking these interface members if by any chance in the database access there is some kind of function. So let me just keep a test function here, public void foo, and this test function, do you get it? If you want to invoke it from program.cs file with the data access, do you get this data access dot? I do not get any foo here, right? I get data, I get data method. That means it's just because of upcasting. What I'm able to do is that I'm just like the last time you seen base class. Similarly, it's a base interface, and due to upcasting, I'm able to access only the base class or here in that sense, base interface members, isn't it? Nothing more than that. Now, if you want to know then what is the other way, that is implicit interface member invocation, that is like this way. So I'm just writing this code here at the top. You are creating directly a new file data access and then storing the reference into file data access itself and say file data access variable with which you write file data access variable dot. Now I can see all those plus I guess I kept that extra functionality foo in the database data access. I'm going to move it to the file data access for a moment, and here it is. For example, sorry, once again. So there it goes. Now from program.cs, you can see with file data access dot, you can get the foo method also, as because it's a reference variable of the class itself. So whatever class members, you can access them directly, correct? Plus the implemented methods of the interface. So this is what is known as, if I just uncomment this line once again and say you are calling file data access dot foo method, and then say you are accessing also file data access dot get data method, or you are accessing this string data is equal to file data access dot data property. These are all what you are doing is you are actually accessing these members via the class. So this is default way we know. This is known as implicit implementation. Sorry, implicit invocation of interface members, right? This is how we do it. And then, sorry, forgot to comment this line. So let's go ahead and comment it. But the explicit invocation, in the sense explicitly you are able to call only the members of the interface that's visible to you. You do not know inside the class if there is any other extra functionality, isn't it? So this is how implicitly you can invoke an interface member, explicitly you can invoke an interface member. It's just that you are doing here upcasting, but behind the scene instance is either of file data access or database data access. And now there is one more option was there. Say for example, what was that explicit implementation? For this, what I'm going to do, I'm going to show you through separate application. First of all, let me see here. iData access is one interface, and suppose say these data property is not part of it. Then suppose say this comes from another interface by the name iData, right? And this had that interface. This had this member, sorry, the property, this string data property, and this interface had this method. Okay. Now what happens, unlike that in C sharp you cannot have multiple inheritance of class feature, remember, but you can have multiple interfaces implement inside the class just separated by comma. Ditto same in the database access I'm going to do, that is I data, I'm going to implement this. So any class can implement in C sharp, any class can implement any number of interfaces they want. Maybe that way you can get as close to that multiple inheritance thing. So you can just take multiple interfaces and then gather all their members inside this uh, inside any class and then provide implementation. But let me tell you, this is a myth that you are trying to solve multiple inheritance problem via interface. That's not true. As because via interface you get methods which are purely abstract and you implement them here. But using multiple inheritance, I can avail the same. I can also have abstract members. If I can inherit from multiple abstract classes, then I'll have many abstract members. I can implement them. But first of all, multiple inheritance of classes banned in C sharp, right? Second thing, if they are not abstract classes, then there is a different thing. Via and consider multiple inheritance is allowed for a moment, then you are going to get multiple members inside this database data access class itself. And that case, what will happen is that you can get them with the implementation. But via interface, you get always the method signature. You do not get the full implementation itself. But if you do actual multiple inheritance as supported in C++, then you can gather lots of implementations already present in those classes, those methods, those methods practically. There is nothing called property in C++. And you can gather them inside a class and then just have them and might create an instance of the class and then invoke them. But it's not. That's why the point is implementing interface, multiple interface and implementing multiple classes or inheriting from multiple classes are not same. If you implement multiple interfaces, you might get lots of methods, but all of them are abstract. But when you inherit from multiple classes, then you get most probably like these abstract methods you can get, which are not implemented, but there is a chance and great possibility that you can get methods which are already implemented in those classes, and you just get them, gather them inside the class, create an instance, invoke those methods, correct? So it's not same. It doesn't solve the multiple inheritance problem up to the full extent. What does it do is that it provides you a functionality to gather certain functionalities present in different interfaces together inside a class and then implement them. And in that process, it's quite possible that you might end up with similar kind of functionality. Say, for example, in just writing here. So here I have a function print, and maybe here I have a function print. Unfortunately, that's a quite common function I do have in both the interface. Now, one thing, it's quite possible since the interfaces have the similar functionality and you wanted this data and get data from those interfaces, you have implemented them both. So now what happens, idata access idata over there, there is a print function. How many times I should implement the print function? So I'm just going to print it and I'm going to write it manually. I hope I'll not make any mistake over there. So that's your print function, and you say return here print. Okay. Now look at this. Errors are gone. Due to same in the database access I have to do. So I'll just go ahead, copy here, and here most probably write file print. And this function, let me copy it, paste it into database data access also, because until unless I implement all the interface members, compiler will not let me go because it will think that that's going to be an abstract class. We'll talk about that also. What happens if the interface members are not implemented completely? So that's your print functionality implemented here also. Right now, let's see how many tests I implemented. One. Why? As because you got the signature. Now you get the same signature from 100 different interfaces or one interface. It doesn't matter. You are going to implement it only one time, right? Is there any possibility that you implement it more than once? Yes, 100% possible. But in that case, you want to keep two different versions of the print function, right? In that case, what you have to do is that you have to write the function exactly like it was given in the interface. And that means no access specified, then interface name. So I data access dot print, okay? And then if you wanted another file print from say I data access, and then this constructor this function one more time, which is I data dot print, okay, and you are saying I'll print access from I data. This is how you can implement the same function twice, which is a rarest case that you most probably need to do. But in this case, what can happen is that this is known as explicit implementation of interface members. Okay. This is called explicit implementation of interface members. When you find multiple interfaces having the similar kind of function, you can implement them with the name of the interface, but that time it is as if like just like an interface. The fact is you cannot implement in some other way. You have to just implement in this fashion without any access specifier. Looks like as if they're inside an interface with the interface name dot method in this way. In the database data access, I didn't do it. Okay, let me just do it in the file data access and you see the difference. Now, so with these data access dot data, let me see what kind of argument. Oh, right. I data access dot data. Sorry. Now, in this application, obviously, if I try to print this I data access dot data, I'm not going to get it as because simply one reason the I data access doesn't have this data. So we're into a double mind, right? What to do? Okay, fine. We can solve this problem a little later. Right now, just trying to see whether how we can make this call. So I'll just comment this line as because data doesn't belong to I data access, rather it belongs to I data. If I make it iData, then I cannot make the call to get data. If I make iData access or data access interface, I cannot invoke this property. I'll come to that problem later. But first of all, let's see. In the file data access, when I have this way, I can, one thing that I don't have this problem here at the top as because it's just file data access, it has got all the interfaces members together, so I can call them. But then if I want to call print method, so I try to write file data access dot, I am surprised not to get any print method. Yes. The fact is explicitly implemented members can be invoked only explicitly. That means suppose a data access dot print method, you can call this no problem. This dataAccess.print method, what it will do is that it will return you, means it will return you obviously the output, but this is the print method of data access, not iData interface. So if you run this application right now, you will get the output. So let me say this is one and see file print from iData access. So it's invoking one of the method. And one thing you notice that you are invoking it explicitly. Explicit interface member invocation. This way, you can invoke both implicitly and explicitly implemented interface members. So both type of interface members can be called the members which has been implemented implicitly or implemented explicitly. Both can be called in this way. But I find it myself bit irony here that when I use file data access dot print here, at that point of time I found that implicit invocation of interface members works only for those only for implicitly implemented interface members. Okay. This works only for implicitly implemented interface members. That means they're actually part of class. Right now, what happened with print? See, if I create an object of here, what do we say that is database data access, suppose say, okay, database data access, and I create an instance of it, I can easily call this database data access dot print method because it has been implemented implicitly, isn't it? But the fact is file data access implements these print method explicitly for two different interfaces, and that's where you have to call them explicitly too. So explicitly implemented interface members can be called only explicitly, but implicitly implemented interface members can be called implicitly or invoked implicitly as well as invoked explicitly, both. Okay. So the way we have written, as you can see, the way we have implemented this method, it looks like as if it's a part of interface. It doesn't make part of this file data access class. Though I have taken this place to write my method still as if it's tightly attached with the interface name. So I'm saying in this way to the runtime, whenever print method has to be invoked, it has to be invoked via iData access only. And in this case, via iData only, right? In this way, it can be done. So now in the program.cs, you can see a starking difference over there. File data access.print not possible to be invoked as because it has been implemented explicitly, but data access Database data access.print is possible as because it was implemented implicitly over there. Whereas this method, as well as the implicit method, both of them can be invoked here, no problem. Whichever it is, implicitly or explicitly invoked members, they can easily be called explicitly, means via the interface, because after all, they were part of the interface which you took in your class and then implemented, is not it? Now, there is the last problem I'm facing is that if I can access get data, I cannot access data because it's of I data access. And again, if I do this, change it to I data, I'll be able to access data, but I'll not be able to access get data, I guess. Yes, that's where the problem comes. So what you can do is you can go ahead and you can say that I data implements or inherits from I data access itself. Yes, quite possible. Interface to interface implementation. Now it might give you an jittery as because already there is a print function here. So there will be hides inherited member, use new keyword if intended. So that means here also you can use this new keyword kind of thing. Not a problem. And then this is the same issue. If you inherit from an interface which has already the same method and you want to have the same method once again, now there will be a small issue, and that is that you have to use the new keyword to make compiler understand, this is just a new print version, not that old print version, like this way. But when I go back to my program.cs file, let me see my problem is solved or not. As I see here right now, it shows that data access does not contain a definition for data and no accessible extension method data accept in the first argument could not be found. Let me see here. I have my iData access, but still it's not giving me any kind of access to the data. As because here I have declared as iData access, which is the base type. So if I declare it as a iData, will that create a problem? I hope not, because iData itself implements data access. Though in the switch case you have given data access, here I am passing iData access, not so sure whether it's going to work or not, isn't it? Right now I'm going to make a change. Instead of making it iData access everywhere, I'm going to make it iData, and maybe I'll keep that variable name same so that I need not to have that pain of changing everywhere. But then this is iData, and now this is what we are returning from here. So as this child type shouldn't be any kind of problem anymore because I'm returning an iData type, and here also I mention it as a iData type, and that's what I'm returning. Only thing is that here I'm saying iData, which is a child type. That's a big trouble, so I'll declare it as, say for example, iData here, and you are good to go. So this interface implement the other interface, correct? Now, the fact is, in order to, it's slightly different. Here, if you declare it as a base type, only base members can be accessed in case of interface, right? And that's what was happening. So here I made it iData. So it has got everything, the getData method as inherited from the iData access and its own data property. Also, the print functionality is there. The question is right now, interestingly, which print functionality will be called? Because in my file data access, there are two, iData access print and iData print. Let's figure out, and you can also guess which print method is going to be invoked because I changed the type in order to suit my coding. Okay, accordingly it's no longer iData access. So am I going to see some other output? Let's figure out. Yes, that's what I expected. File print from iData. So depending on the type of interface, either this print method or that, sorry, this print method or that print method is being invoked. It depends on you how you want your code to react. But in order to solve the problem, I just wanted to show you that interface can itself inherit from, and it's also quite possible that if you have the similar functionality and you want to say that this is a new version of that print, you can take it and provide your own implementation also. But that's a rare case. You most probably will not have this kind of problem. So I'm just going to remove this print method. But if I do it, then it makes no sense for me to implement them separately, as because none comes from iData access, all comes from iData itself, isn't it? Not required. So let me keep this to show you explicit interface implementation, interface to interface inheritance, interface to class implementation, everything. Now, as the last part of all, let me just tell you, say for example, here I have a functionality, say string foo, just an additional functionality. It returns some kind of string data, isn't it? or say some kind of integer data. Whatever it is, if this is the functionality and you have decided to not to implement, if you have decided not to implement, then at least you are going to have to write this method public abstract int foo. The reason for this is don't implement it, we don't mind it. But then in that case, you have to make this class as an abstract class. Okay, maybe I'll do it in a separate place. Say, for example, say this class I don't want to hamper. I have already created an object of it. So I'm just creating here a class by the name data access, or maybe not here. Let me just add a separate file. Say in this application, adding a class by the name data access. And in this data access class, I'm just going to implement the interface iData access separately. And then I'm going to implement iData also here. And in that case, whatever you want, it doesn't matter. Just say, I'm going to implement here some interface. And if you do not want to implement them, all of them, let me take iData access, not iData. I just do not want to link this class. I want to show you separately what happens if you do not implement one interface member, right? So here, say iData access has got two things. One is the method getData, another is the print most probably. I do not want to implement one of them. Say public, or first of all, let me write these functions, implement these functions first. Then I'm going to make one of them. So getData is not a problem, but print I do not want to print here. Okay, I do not want to implement it. If you do not want to implement, you have to make the function or declare the function with print. That's all. You just cannot leave it as it is. And side by side, you have to declare the class also with abstract. Because you said one of the interface member I'm not trying to implement here. So if you're not trying to implement, what is the problem? Just don't write it. No, it doesn't work that way because it's interface to class inheritance. In case of interface to class inheritance, do understand in interface, this method is by default abstract, by default public. But when it comes to the class, then the fact is in class, no method is by default public and no member practically is by default public and no member is by default practically abstract. So what happens simply is that in the class, if you just think about it, it's behind the scene like this way. What does it mean? Private. But does it mean abstract? No, obviously not. So that's where any interface member, if not implemented, has to be written at least inside the class. And this is the way to do that. Public, abstract, you have to just attach those keywords which are not present in the interface. Then most probably there will be some other class which will implement this or inherit from this class. Say, for example, database access class, etc., etc., isn't it? So this is how, if you do not want to implement any kind of method over there, so this is how it should be done, isn't it? So I'll just say this for method. Yeah, done. Let me see anywhere else I have any other issue. I did access. I've got an extra method foo. Okay, fine. So I have to implement yes everywhere this foo method. That's not a big deal, isn't it? So I already have this method. Oh, I have to change its return type to int, isn't it? That's how. That's how. So if it's supposed to return an integer, and then say I'm returning 0 from here, and if it's supposed to return here too, so return say 1, some kind of value. Just wanted to show you, isn't it? So conclusion. First, an interface is declared in this way. Interface keyword, no public access specifier with the members, no abstract also with the members, as because by default public, by default abstract, all the members in interface. You cannot declare any kind of data member, no static member, no constant, no data members, nothing at all inside this, only function or only property. Either means function and property, only these things could be there. Interfaces are named, interface naming starts with uppercase I to indicate that it is an interface, but pronounced as data access interface, not iData access like the way I was saying. I just wanted to make sure that you got that idea, that's why. But when it's pronounced data access interface, I have a data interface, etc. This way we say. Interface to interface inheritance is possible. It's also quite possible both the interfaces having the same functionality. In that case, you can use once again new keyword to say to the compiler, see, I'm trying to tell you that it's my new print function. It's not that one I have inherited, isn't it? So this is what I can do here. Next, any class's job is to implement those interface. We do not use the term inheritance as such. We use the term implement the interface. Now, when you say implement the interface, you must implement every member of that interface. Otherwise, what is going to happen is that, take for example, if you do not want to implement any interface member, you have to at least write it write that member or the members which you do not want to implement using public and abstract keyword, isn't it? So public abstract string print, this is how it is. And obviously the member that you have implemented, you can implement in this way or you can implement it in an explicit way. You know that drill, correct? So if you want to implement this way, this is fine. This is known as implicit implementation. Or else if you want to implement it in explicit way, so there it is, I data access dot get data. You can implement this way too, no objection. So this is explicit, and the other one, sorry, my mistake, and other one is implicit way of implementing. So in that case, you write public void add get data functionality, no objection, like this way, obviously. Okay, so you can implement in both ways in that class itself. But if you do not intend to implement something, public abstract. That's because by default class members are not public, nor it is abstract. So you have to keep it over there this way. Now we can implement the inherit from this class and can go ahead and implement those methods over there in the child class right now. Now, when you are implementing, there are two ways of implementing. As I showed you, implicit way implementing, and there is something called explicit way implementing. But as well as they have a technique also. When in your application, if you want to invoke those interface members, there is one way: create the instance of the class and store the reference in a variable of the class, so you can access anything, the classes members, the interfaces members, everything. So it seems to me that implicitly implemented interface members can be invoked implicitly, but I found that the print method was not being called in that way. It's not possible to call, as because explicitly implemented members are supposed to be invoked only explicitly, as you can see below, with the interface variable name, as because I have told that only it can be invoked via the interface member variable. So no one gets an idea what is inside the class. It's actually a way of telling you that I do not want to reveal the class. You should have only have the interface members. If the class has got any internal members, you are not privy to that. So it's kind of a filtration mechanism that only interface members will be called. Nothing else is matter to you. Only these things do matter. That's all. In that case, it's very useful to declare the members explicitly also forcefully. Now there is no other way but to call it via the interface. Nowhere there is no object involved here directly, but indirectly. Obviously there is an instance because the functions are being called from that instance also. Also you can do upcasting here in this way, like the class, etc. So it makes sense. Now, the vital question, what is the difference between the abstract class and interface then? So you have seen that interface is mainly for this agenda, that I have certain functionalities which I want to be injected inside each and every class or to be inherited by each and every class, then should be implemented over there. In that case, interface is the best thing. And it's just a kind of function table which you can take and implement whatever you need. Okay, but in that case, while implementing one more thing also, you don't need to use override keyword, right? But in case of abstract class, what happens is abstract class says that this any abstract class, first of all, let me open that old application abstract class, correct? So here it is. The abstract class, it's not everything over there is abstract. It could be some things could be non-abstract members also. It can have data, it can have nice interface constructors. By the way, in interface you cannot explicitly write any kind of constructor, nothing except the data, except the method and the function. Nothing else can be written inside, not even the constructor explicitly. Okay, so you can have here data members, constructors, some other regular properties, regular methods, virtual, non-virtual. But side by side, you can have abstract method or abstract property or both of them, etc. But then this is a class. It can have data, whereas interface is just collection of functionalities. It is very useful to inject some kind of additional functionalities that you want in your class via the interface, and you can also use the interface to hide the object. Practically, I can say interface is nothing but like a contract which tells that most probably there is a class, and obviously there is no doubt there is a class. The class implements this kind of functionalities. So if I say, I have got a database data access class, and certain functionalities that over there. If you say which are the functionalities, please show me that. Then I have to open this class file, isn't it, to show you these functionalities, but then I expose the code also. Without that, what I can do, I can create an interface, link this interface class and the interface here, and I can tell you, you wanted to know that how many functionalities are present in my class, and these are the functionalities. In this way, you are doing two things. First of all, you are not revealing the actual source code of those functions, which are hidden inside the class, but you are telling or exposing to the outside world, I have so much, these so and so functionalities implemented in my class. Second of all, also in your class, there might be some extra functionalities which outside world need not to know. So you can declare an interface and put only those functionalities which you think should be exposed to the outside world. In that case, interface acts like a contract. It hides lots of implementation inside the class, also does not expose the unnecessary things which are internal members of the class which you don't need to know maybe. So I can be selective and choose which functionalities to be exposed to the outside world, and I can use an interface and then link this interface with the function. Anyway, these functionalities are implemented inside the class. So this is a great way to tell to the outside world or anyone that I have so and so functionalities that you might be interested in. Please take this, and behind the scene will provide the reference of this instance which will be created behind the scene will be supplied to you. But that's a part of a design pattern, how it can be done without telling you that there is a class behind the scene, isn't it? But as of now, this is what is about interface, a great thing that you learned about it here in this video. Hope it will be useful to you, and go ahead, explore more on interface, explicit interface member implementation, etc. from internet, from Microsoft website, that is the MSDN website I'm talking about, or many other like you have got different websites to look at, tutorials point, etc. Also you can look at it. Okay.